All right, guys, let's look at the first one here. So I'm going to start on the left side of this one. So I'm going to look at this side over here first. And I see two things being subtracted, both raised to the fourth power. And what that reminds me of, and it may not immediately be obvious, but if you think back to when we were factoring and talking about the difference of two squares, that's what that looks like to me. That looks like something squared minus something else squared. And if we remember how we can rewrite this, so I guess let's take a step back and let's talk about what a and b are in this case. So in this case, since this is raised to the fourth power, a would not just be sine of theta, a would actually be sine squared of, and I said theta, I meant x, sine squared x. So sine squared x is being squared. And then b, you can probably figure this one out on your own. So b would be cosine squared. And that whole thing is being squared. So b is cosine squared, a is sine squared, and they're both being squared again. That's where we get this x to the, or the sine x to the fourth power, excuse me, and cosine x to the fourth power. And they're being subtracted. So we have a difference of two things being squared here. And so if you remember how we can rewrite that, let's make it red again. So we can rewrite the difference of two squares if we wanted to factor this into a expanded form. We could say, well, let's do it up here. So a squared minus b squared is the same thing as a plus b times a minus b. So if we FOILed this back out, a plus b times a minus b, it would go as a squared minus b squared, because the middle terms would cancel because we have this plus and minus. So I'm going to rewrite this here now as a, so sine squared of x, plus b, so plus cosine squared of x, times, and now a minus b. So this is a plus b, right? Sorry. This is a plus b, and so a minus b would be sine squared x minus cosine squared x. All right, so I'm getting somewhere here because I have a sine squared on the right side that I'm trying to get. So basically the only trig function I want left when I'm done is sine squared of x, because I'm ultimately trying to get this side of the equation, this left side of the equation, to look like the right side over here. So I want them to look the same. And so let's think about what else I can simplify here. So I'm going to use my trig identities, my Pythagorean identities that we talked about. So I know that sine squared plus cosine squared is the same thing as 1. So if I have 1 times sine squared x minus cosine squared x. All right, so we're getting somewhere here. So I've got my sine squared x. I still need to get rid of this cosine squared because my final answer doesn't have a cosine squared in it. And so the way I'm going to do that is what else can I rewrite? Again, using the Pythagorean identities, I can rewrite this cosine squared, because remember that, let's see, let me write it over here. Remember that sine squared x plus cosine squared x equals 1. So if I rewrite this, I could also say, I'm just going to subtract sine squared x from both sides, that cosine x is equal to 1 minus sine squared x. Right, so this is also true. And so I'm going to substitute that in for cosine squared here. So I'm going to rewrite this now as 1 times sine squared x minus 1 minus sine squared x. So now I've got everything in terms of sine squared, which is helpful because that's ultimately what I need to get up here. And so the last thing I'm going to do is distribute this out, and let's see if we can't get something that looks like 2 sine squared x minus 1. So let's see, how can we do that? So I'm gonna leave my, well, multiplying by anything by 1 is just gonna leave it. It's gonna be the same. So I'm just gonna ignore the 1 now. The 1 is just being multiplied. So I've got sine squared x, and now I'm gonna distribute this negative sign into these parentheses here. So I'm gonna have minus 1 plus sine squared x, right? Because a negative times a negative gives me a positive, so plus sine squared x. And if I have sine squared plus sine squared, that's going to give me 2 sine squared x minus 1, and fingers crossed, there we go. So that is equal to the right side of our equation up here, which is great. So that is equal to 2 sine squared, minus 1. So we just verified that identity. So I just wanted to show you the step-by-step way that they went about solving that one. Now you can move on and look at number 2.